Hello everyone, I am back with the new GPU pass-through video, but unlike all the previous videos, in this one we'll be using Windows 11 as our guest operating system. Windows 10 should still work just as well, but we'll focus on Windows 11 in this one. I'll be using a new and updated script for this video, and the link will be in the video description. So the requirements, as always, are you will need 2 graphics cards, one for the host, one for the guest. An integrated graphics card should be enough for the host. Intel graphics cards, AMD APUs, they all should do just fine for the host. For the guest, you will need a dedicated graphics card. Next, you will have to have the virtualization extensions enabled in BIOS, VTD, VTX on Intel, and SVM and IOMMU on AMD. Usually the names can vary between different motherboard manufacturers. Another BIOS setting that we need to change is we need to disable the resizable bar feature in the BIOS. Again, that needs to be disabled, and above 4G decoding, if you have that setting in your BIOS, that needs to be disabled too. Okay, and now that we have the requirements out of the way, we can get started working on our Manjaro host. Sudo pacman -syu will make sure that our system is up to date. So now that we've downloaded and installed the updates, let's reboot. Next up, let's download and run the script. The link will be in the description. Download zip, we'll save it. Okay, so let's open the file manager. Let's unzip it, extract here. Let's open the terminal. Let's go to downloads, Manjaro helper 21, and let's make manjaro_help.sh executable. chmod +x and manjaro_help. And now let's run it as a super user. So sudo manjaro help.sh, enter. Okay, so this will make some changes to grub. Basically, it will change this IMD IOMMU on, this so that the vfio.pci is loaded before NVIDIA, and this to avoid some blue screens. If you want to edit it with Nano, just hit Y. If not, then N, and let's continue. This should be good, so I'll hit N. Yes to all the installations that will be happening. Yes again. Next up, if you want to use Windows 11, you will need a trusted platform module. And if you don't have it, you will need to emulate it. So if you want to install an emulator for that, hit yes. mkinit CPIO was modified. Do you want to make changes to it? I will say no. If you want to modify it yourself, or if you want to take a look at the changes, hit yes. Okay, so here we are done with the script, and at this point we should reboot. Okay, so we are back. Now let's verify that it's actually working. We'll go back to GitHub. We'll download IOMMU viewer. Same process. Extract it. We have to make it executable, chmod IOMMU viewer, and let's run it now. Okay, so what this will tell us, it will tell us what IOMMU groups our devices are in. We want the graphics card will be passing to the virtual machine to be in its own IOMMU group. In my case, it's this one in group 2, but there is another card in group 2, so there are 2 cards. There is a Radeon 6900 XT, and then there is a Radeon 5400. So the 5400 I'm using for my host, and the 6900 I want to use for my guest. But because they are both in the same IOMMU group, I cannot run this. So what do I need to do? Well, I either need to move one of them. I could take in my first slot, it's the Radeon 6900, and in the second slot, it's the 5400. So I could move the 5400 to the third slot, but that one is kind of blocked so I cannot put it in there. So what I can do, and you can do that if you are on Ryzen. Generally, Ryzen systems have this option. So I'll reboot and go to BIOS. And in BIOS, I'll go to, I think it's under AMD CBS. If you have something other than Gigabyte, it will be somewhere else, and it will be probably called something like ACS Enable. And I save it. IOMMU viewer, and let's see our IOMMU groups. Okay, here we are. Now our graphics card is in two groups, 26 and 27, and that's fine. Nothing else is in any of those two groups, so we should be good to go. The 5400 sits in its own group, 28. Perfect. So all you want to do is any device you decide to use with your virtual machine needs to be in its own IOMMU group, or in this case two, but they cannot share an IOMMU group. Next up, we'll need to download the Windows 11 ISO from Microsoft's website. Okay, so now let's open Virtual Machine Manager, and we'll create a new virtual machine. We'll pick the CD-ROM and find it where we saved it. I'll give it Windows 11 16 gigabytes of memory. I'll pick 4 cores, 100 gigabytes of storage. That's what I'll give it. And then customize. Okay. If you are doing Windows 11, you need to choose Secure Boot, NQ35, apply. I mean, we can change the name to 11, it doesn't matter. Boot options, I'll make SATA bootable. It's bootable by default anyway. The first time you run it, it will boot from that device. But sometimes you might need to reboot the machine or something, and it's just nice to have it selected. Next, add hardware, and we'll do the Trusted Platform module. When we ran the script, it installed the emulator, so we should be good to go there. My PC does not have a TPM chip in it, so I need to emulate it. If you do have the Trusted Platform module chip, then you can just do passthrough device, and this should be the name. But if you don't have the chip, or if you just don't want to mess with it, you can always use the emulated device. Doesn't really matter. You just need to convince Windows 11 that it's present there. So we'll go with the emulated device. Finish. We won't be doing the pass-through just yet. We'll get the machine going, and when everything is ready, we'll add the graphics card. So I'll click on Begin Installation. Okay, so Windows is ready here, and let's shut it down, and let's add the graphics card. Okay, we'll need the actual graphics card, and you'll find it under PCI host devices, and you just have to find which one is the one. So so I add this one, and then there is an audio portion, and you want to add that too. So right here, finish. Okay, so we have these two. That's the same graphics card, the video portion and the audio portion. And then you also want either USB devices, like a mouse and keyboard. You can pass them through individually. I would recommend passing through an entire USB controller. That way you can plug in and unplug USB devices, and it gives you more flexibility, and some things work better that way. So in my case, I know this one sitting in its own group right here. I will use this one, 0E00.3. So PCI host device, and then you will plug in your mouse and keyboard to that, and you will basically need 2 sets of mouses and keyboards, or a KVM switch. You could use EVDev for mouse and keyboard switching between the host and the guest. It's a topic, it's an entirely separate topic, so I won't go into that. But if you only have one mouse and one keyboard, you can unplug it from the host, basically whichever controller is, or whatever controllers are used by the host, and plug it into that one controller you pass through to the guest. and you will be good. And because it's an entire controller that's assigned there, you can plug in devices and unplug devices. If you do an individual USB device like this, you cannot plug in and unplug them. They are basically assigned at boot and you are done. We'll keep the emulated GPU here while we are installing this, because AMD graphics cards need the driver installed, and in order to install the driver, you will also need to edit the XML. So we'll do that now. But before we can, let's go back to Virtual Machine Manager, the main screen or whatever, and click Preferences and enable XML editing. When we select this, click on this, Edit, Connection Details, and Virtual Networks, and select Auto Start on Boot. That way you don't have to manually start the network each time the host machine starts. And let's edit XML. I'll go Overview, XML. So I'll go back to GitHub. You need to paste this between the Hyper-V tags in the XML, and that will let your AMD GPU to basically work. Without it, the drivers won't work and you won't have any output. Okay, so between Hyper-V tags, let's find that. And value, I said not a VM, so whatever, you give it whatever name you want. You're just trying to basically convince the driver that this is not a virtual machine. If you have an NVIDIA GPU, don't worry about this. This is only for AMD GPUs. NVIDIA GPUs should work just fine. You should be able to install the driver and you should be good to go. AMD, you might have to do this. Okay, apply, and now we can start the virtual machine. Okay, so let's download the driver and hit install. So let's shut down the virtual machine, and what we'll do, we'll remove the emulated graphics card, starting with tablet. That allows for relative mouse movement, relative between the virtual machine and the guest. So we won't be using the same monitor, basically. We won't be seeing output in Linux anymore. So we'll remove all that. Display spice. We don't really need that sound device. If you want sound, you can just use a USB sound card, or I would recommend something like that, or your monitor if you can plug in speakers into that. Channel spice we can remove. Video QXL we can remove. Okay, at this point what we'll need to do, the graphics card we just passed through, you need to plug it into another monitor. Some people only have one monitor. You might have to either switch inputs, or you might just have to move the cable from one card to another. If you have two monitors, you will be getting output on both of them. One from your Linux host and another one from the guest. And again, mouse and keyboard, you will need that too. So let's start this. Okay, so we are in Windows now. I will go download 3D Mark and I'll run it, basically just so we can see how this virtual machine performs without any optimizations. Then once we are done with that and we see the scores, we do some optimizations and we'll see how we perform. So I'll be right back with 3D Mark. So I installed 3D Mark and I will run it now. So CPU score is 2000, graphics score is 14,000. Okay. Let me shut it down. Let me plug my monitor back into the host and let's do some optimizations and we'll see what score we get afterwards. Let's first take a look at our CPU right here, and 8 cores, but when we look at the topology, it's all sockets. So I like to set it as cores. You can do threads too, let's say 4 cores, 2 threads, whatever. This is a 12-core CPUs with SMT, so that gives us total 24 logical CPUs. I could go higher, but doesn't matter. For testing purposes, this is enough. Next, let's click on Overview and XML, and we'll go right here. I went over some of these in the previous video, these optimizations, so I kind of refined them a bit more. These seem to perform the best. If you want to know more about them, you can watch the other video. let's just append it to Hyper-V. So here it begins here, relaxed, VAPIX, binlogs, vendor ID, and we'll add this to the end, apply it, just to make sure it's all good. Then next, core pinning, run ls cpu-e, and what we'll see is, right, we have our 24 logical cores, and I mean our logical core 1 responds to, well, core 0 responds to core 0, core 1 responds to core 1, and so on and so forth. But once we reach core 11 and we start with 12, we again go 0, 1, 2, 3. So this is basically SMT or hyperthreading, right? The one core serves 2 virtual cores. If you turn off hyperthreading, it would be just 0, 1, 2, 3, 4, and so on, corresponding to exactly the same one. But in this case, you have to keep this in mind. So let's say you have a 2-core virtual machine, and you assign core 0 and core 12, where you are not really assigning 2 cores to it, you are just assigning 1 core with SMT, so hyperthreading, whatever you want to call it. So keep that in mind, run lscpu-e to see how your machine looks. So I adjusted this to my needs, so don't just copy it, because it might not work as such for you. Okay, so let's find vCPU right here. vCPU, and I'll just paste it right here. Okay, apply. So that should do. IO threads, these are some basically other threads that the virtual machine or the hypervisor needs to serve the virtual machine. So you basically assign some unused cores to it, and you don't have to assign these IO threads and emulator pin. You can just skip it, and you can only go with core pinning. So it's up to you what you do. Okay, let's run the virtual machine, let's run the benchmarks, and let's see what happens. Okay, so our score definitely improved. We went from like 2000 on the CPU to 8000, and I think we almost doubled the overall score, or we more than doubled the overall score. So yeah, I hope you found this guide helpful. Thank you very much for viewing, and I hope to see you in the next video.